Hello friends, welcome back to another video on the same series, that is May 2020 RTP. Now this is a bit special video and the next video also. So all to my students and friends who are watching the pen drive classes as well as in YouTube, this is a really important video, this one and the next one. Why? Because we are continuing with May 2020 RTP, but if you can see this question, especially the eighth one, and so many students have messaged me also that they have found a new word here called takt time. It's a German word actually. Anyway, we'll see that in the next video. Apart from that, there is one more important thing which I don't know how many of you have noticed in this particular question. That is, as you can see here, this particular company decided to practice single piece flow under JIT. Can you see this? Single piece flow under JIT. Now, normally what I see is many of the students, they feel that it is normal JIT. They don't really understand what is the uniqueness of that particular word, and they just try to move on with the question, but that's not the right way of solving. So as a result, what I'm going to do is that so far I've done 5 videos. Still, sixth problem and seventh problem needs to be done. After that, only the eighth one I'll be doing eventually. But before that, I'll just try to explain you the concept. One is what do you mean by single piece flow under JIT, as well as tuck time in the next video. Okay, let's finish that off first. Let's finish off the concepts. After that, I think if I'm not wrong, so far I'm done with 5 videos. I'm not really sure. And if that's the case, then I'll start with the sixth one and, you know, 7 and 8 and so on. Anyway, chalo. Okay, guys, now come to this problem number 8. We are not going to solve the sum. Please try to understand. I'm just going to take the concept. So what is the concept? Single piece flow. So what do you mean by that? Let's try to have a basic understanding and then we'll try to understand it in depth. So single piece flow or one piece flow. So basically it means the parts are moved through operations, that is multiple operations, operation 1, 2, 3, 4, 5 and so on, from step to step with no WIP. So this is the keyword. So which means if you as a company, you are following JIT with single piece flow, that means there will be no WIP in your manufacturing process, which means either it will be one piece at a time or small batch at a time. If you are following batch costing, it goes that way. It ensures that there is no work in progress. So that's the whole concept of single piece flow. Okay, so what are the advantages ultimately due to single piece flow? Why should I follow it? Very simple. When compared to the traditional batch and queue system, it is faster. How is it faster? We're going to prove with an example. So don't worry about that. I have an example below. I'm going to prove with an example how it is faster when it comes to traditional batch as well as queue system. Queue system means where the products used to wait for the next process to happen, which means definitely there will be work in progress, right? So speed factor also allows us to wait longer to schedule the order and still deliver it on time. Because of this one piece flow system or single piece flow system, because you can manufacture the units faster, so that gives us the flexibility to wait longer even though we have received the order, so that we can schedule the order, okay, at the what do you call later point of time and still deliver the order within the time which we have committed to the customer. And also it helps us to better able to respond to last minute changes from the customer. Why? Because you just try to manufacture one unit at a time. Therefore, even if the customer tells you that these kind of last minute changes I need, you'll be flexible enough to do that. So all these are plus points because of single piece flow. So what are they, guys? So first of all, what is the concept of single piece flow? Parts are moved through operations from one step to another step without work in progress. So the keyword is there will be no work in progress. So either it will be each piece at a time from one operation to next operation, or it's going to be small batch at a time. So what are the advantages because of that? It is faster than traditional batch as well as queue system. Speed factor, because it's faster, it allows us to wait longer to schedule the order for the customer, yet deliver it on time. That's the most important point. And also it gives us the flexibility to respond to the last minute changes that is given by the customer, because I manufacture one unit at a time, and that too I do it faster, and that too I wait longer, and then I do it at the ending. So therefore, if at all there is any changes from the customer, I will be able to do that. Got it? Okay, as I told you, I'll prove these things with an example. So let's go to the example. Now listen carefully. Okay. So traditional manufacturing, how it works, see here. Let's say these boxes are workstations. What are these boxes? Workstations. Okay. Operation 1, operation 2, 3, okay, 4, and 5. Okay, all these boxes are workstations, and you have got people over here. So workstation is the box and people over here, because you need people as well as the workstations to complete a process. You need machine as well as man, correct? That's the concept. Anyway, so for ease of understanding, what I've done is I've presumed that one unit will take 1 minute. It's easy to understand, right? Because our ultimate intention here is to understand the concept clearly, right? So no confusions whatsoever. So to understand the concept, I just took a simple example. Let's say one unit will take 1 minute. Each piece takes a minute. That is the logic, correct? And also each step is a 1 minute process. So each unit will take a minute. At the same time, each step, single step, is a 1 minute process. So going by that logic, let's say you have 10 pieces at the beginning. This is inbox and this is outbox. Every process will have an inbox, that is the raw material for that particular process, and the outbox, that is finished good for that particular process, but for the whole product it's still WIP. You got the point? Anyway, so I have inbox, I receive something, I process it, and then I send it to another process, which means through outbox. You got the point? Anyway, so in inbox here, as you can see, how many pieces I've got? 10 pieces. Okay, 1 2 3 4 5 6 7 8 9 10. Got it? All right. Anyway, so we know that one unit is going to take 1 minute. So which means each process, each step also is going to take 1 minute. So which means this particular unit in step 1, it's going to take 1 minute. And after 1 minute, one unit will come here, correct? After 2 minutes, 2 units. 3 minutes, 3 units. 4, 5, 6, 7, 8, 9, 10. After 10 minutes, these many units will come, and this will be transferred to the next step, which means how much time it will take eventually? 10 minutes. And step 2 will have all its input, that is 10. Got it? Now again, step 2 also is a 1 minute process, and one unit will take 1 minute, correct? Which means what's going to happen here? Again, it will take exactly 10 minutes. So after 10 minutes, in addition to this 10 minutes, which means after 20 minutes, you'll have 10 units over here, correct? And then this will be given as an input to step 3, and another 10 minutes over here for 10 units. So 30 minutes you'll be out of step 3, and 40 minutes you'll be out of step 4. Are you able to understand? So that's how it's gonna happen. Anyway, now see here carefully. Here I've received 10 units: 3 4 5 6 7 8 9 10. By this time, how much time would have happened? Still we are at the entry of step 5, which means step 1 is done, 10 minutes ho gaya. Step 2 is done, 10 minutes ho gaya. Step 3 is done, 10 minutes ho gaya. Step 4 is done, 10 minutes ho gaya. Totally 40 minutes is done when you have got the input for step 5 in the inbox. This is the inbox for step 5, correct? Now let's say how much time it will take for one unit in step 5? 1 minute. So which means now I've got one unit over here, which means to get the first unit, now this is finished good, correct? Now that is finished good. Just a second. Okay. Right, guys. Now see here. Now this is finished good, correct? This is not finished good. This is not finished good. 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 Correct? Why? Because all these are WIPs. Only after finishing of 5 processes or 5 operations or 5 steps, here I've got the finished good. So to get the first finished good, it's gonna take how many minutes? Step 1, 2, 3, 4. 10 into 4, 40 minutes plus 1 minute for this one unit. So first piece will be completed in which minute? 41st minute. Okay, so if you want to get the first unit under traditional manufacturing, it takes you 41 minutes. And 42nd minute, you'll get the second unit, 43rd, 44, 45, 46, 47, 48, 49, 50. So all 10 pieces exactly you'll be getting in how many minutes? 50 minutes. It's not pieces, minutes. Are you able to understand? Right. So as per traditional manufacturing, I'm gonna get the first finished good in 41st minute. So I need to wait for 41 minutes, and I'm gonna get all the remaining 10 in another 9 minutes. In the sense, it's gonna totally take me 50 minutes to get all my 10 units or 10 pieces of finished good, right? Okay, so this is your traditional manufacturing process, that is batching kind of system. Okay, right, now let's go for single piece flow. Now see here, this is single piece flow, that is one piece at a time. So what basically happens, you get your first piece over here, 1 minute it comes over here, right? And then within 1 minute it goes over here, 1 minute, 1 minute, 1 minute. So on the 5th minute itself, you'll get your first piece. Now continuously it happens. Just try to imagine. I cannot show graphics over here. Just try to imagine. One unit goes from here to here, another unit comes here. This goes from here to here, another unit comes here. This goes from here to here, another unit comes here. This goes from here to here, another unit comes here. This goes from here to here, another unit comes here. So it goes like a chain reaction. Imagine, chain reaction. Okay. First step to another step, one unit. Got it? Here another unit will come. You see here, see my both the hands. So this is from first step to second step, this one, this hand. Okay, this is first step. Okay. Now see what happens. This goes second to third, this goes first to second. Are you able to understand? Now, are you able to understand? Again, I'll repeat. So this is the first one, 1 to 2, 2 to 3, this is 1 to 2. 3 to 4, this is 2 to 3. You understand the point? And 4 to 5, this is 3 to 4. Are you able to understand? Like that, it just keeps on going. Now see here. Again, I'll repeat. 1 to 2, 1. 2 to 3, 1 to 2. And here 1, another 1. It will follow. You got it? 3 to 4, 2 to 3, 1 to 2. And then again 1 will follow. Are you able to understand? So that way you will get everything one after the other, but one unit will be manufactured at a single point of time, not multiple things. Are you able to understand? So which means the first piece you will get in 5 minutes, and 1 more minute it will follow up by another piece, 1 more minute it will follow up by another piece, 1 more minute, 1 more minute, 1 more minute, 1 more minute. So which means 9 more pieces within 9 more minutes, which means totally it will take only 14 minutes. See? You can tell me, sir, it is just like a common sense concept only. Now, what is there much in that? See, the point here is who are applying common sense nowadays? It seems simple after giving it with an example, but that's not the case in real world. Anyway, so it affects all the following positively. Okay, so what are they? Inventory cost will be reduced, obviously, because there is no WAP stock. Quality gets improvised because of JAT eventually, and JAT, if at all you want to implement the prerequisite of JAT is TQM, so automatically quality will be improvised. Customer service will be better. You got it? Labor time will not be unnecessarily wasted. Productivity will be increased, that is efficiency, and lead time also will be reduced because now we can manufacture things faster. Lead time is nothing but the time taken by the supplier to deliver your order from the moment it has been ordered, correct? And if we are the supplier, I can easily make things faster now. You got it? Point. Anyway, chalo. So, what would you do with an extra 30 minutes or more every hour? Correct? Because as per traditional, it was taking 50 minutes. As per one piece flow, it is taking only what? 14 minutes, which means literally you're saving 36 minutes. So, what would you do with 30 minutes every single hour? Look at the impact of one piece flow. That is the power of lean system. Are you able to understand? That's the concept. I hope you guys have understood this concept clearly. See, one thing please try to understand. Costing, especially SCMPE and costing, is very interesting subject, provided if you have learned it in the right way. Unfortunately, in India, we cannot, we don't have those kind of facilities to actually go inside the factory and then see how things are happening. If that facility is provided, then costing will be most interesting subject for you. Unfortunately, that's not happening. So all that you need to do, if at all you want to become, so many students will be asking me, sir, you got the sort of expertise in costing, now how is that possible? We also want to do that, but majority of us, we find this particular paper as difficult. The logic is very simple, Anna. All you need is imagination. This is the solution, 1 point solution. All you need is passion towards the subject, commitment, and imagination, most importantly. So when I was explaining you this example, this single piece flow, one after the other, when I explain you the concept, you have to imagine. So when you read it, you have to imagine, okay, how it happens. If you are able to imagine things better, costing will be the easiest subject for you. So that's how it works actually. Are you able to understand? Anyway, so this is the concept of single piece flow under JAT. You got the point? Very important to understand this particular problem and any future problems also. Okay. And as you can see, I've made the notes for tuck time also. So this I'll try to explain you in the next video. So right now we are done with one of the most important concepts over here in May 2020 RTP, that is single piece flow. Got it, guys? So if you have really liked this video and you have loved the explanation, hit that like button and don't forget to comment, guys. Of course, subscribe also. Okay, your comments are very important for me. It gives me immense happiness, right, guys? So thank you so much. This speaker is signing off. See you, bye bye, in another class.